Now in this question number 5, we are told that an arithmetic progression has the first term 3, the sum of the first 10 terms is 4 times the sum of the first 5 terms. So since the common difference, we don't know it, we can say let the common difference be d, and the first term is 3. So which will mean that we shall be using the sum of n term formula in order to find the sum of the first 10 terms. Shall find the sum of the first 10 terms, which is going to be 10 over 2 because n is 10. So we shall say 10 over 2 into 2 times the first term, which is 3, 10 minus 1 into d. If you simplify that expression, you shall get 30 plus 45d. So that is the sum of the first 10 terms. Then we're going also to find the sum of the first 5 terms in this case also. And finding the sum of the first 10 terms, 5 terms here, the expression is going to reduce to 5 over 2 into 6 plus 4d. And now since we were told that the sum of the first 10 terms is 4 times the sum of the first 5 terms, so we are going to say first sum of the first 10 terms is equal to 4 times the sum that we've got here for the first 5 terms. So if you equate this and try to put the like terms together, you are going to find the value of d being equals to 6, because we shall equate this equation, we simplify, put the like terms together, and the value of d is going to be 6. Now another type of question you can be asked is where you are given an arithmetic sequence and then you are told that it forms a geometric progression. So here we are told the first, second, and fifth terms of another arithmetic progression are first, second, and third terms of a geometric progression. So meaning that if we let the first term to be a, we can be able to say that the second term will be a plus 2 minus 1, because in second term the n is 2, then minus 1 into d, and that is going to be a plus d. But if we are finding now the fifth term, we are going to say now with our fifth term it will be 5 minus 1 into d, and the expression now becomes a plus 4d. So with that expression, expression for a first term, second term, and fifth term, we have forms the first 3 terms of a geometric progression, which is a plus d, a plus 4d. And meaning that if you want to find the geometric ratio, common ratio, it will be the second term divided by the first term, and third term divided by the second term, so that we can be able to form an equation like that. So if you say a plus d over a is equals to a plus 4d over a plus d, then if you try to simplify this, we're going to get our d's, putting the like terms together, we shall get d squared is equals to 4a minus 4ad minus 2ad. So meaning that if you write your value of d in terms of a, we are going to have our equation well simplified at this point. So meaning that d is 2a. So if we want to find common ratio, we can be able to substitute where we have d, we can substitute 2a, and that is exactly what I've done. In order to substitute, I've replaced this one here. I believe you can be able to see that. So if you substitute anywhere you have d with 2a, this expression here is going to be a plus 2a, and that's going to be a plus 2a, which is going to be 3a. So meaning that first term is a, second term is 3a, then meaning that their common ratio will be 3a over a, which is going to be 3. So basically that's what you are going to, or you are supposed to do, in order to get the common ratio in a question like that. Moving to the question on modulus, this is a question that whenever you are working it out, you need to remember what the modulus does. If the expression inside here was a positive, that expression will become positive. So meaning modulus will change the sign. So we were to form an equation, say the first equation will be x squared minus 5x is equals to 6. And also, if you try to rearrange this so that you have a quadratic, it becomes x squared minus 5x minus 6, because this was on the other side. It will change the sign once it goes over the equal sign. And then if you factorize this, you're going to get x minus 6 into x plus 1. So meaning x is equals to 6. By equating the whole of this equals to 0, make x the subject, you are going to get x is equal to 6. And also if you equate this to 0 and make x the subject, you shall have x is equals to minus 1. And the next option is where you are going to say anything that is in the modulus is going to be equals to negative 6. Then so you form another equation, quadratic, and if you solve it as shown here, you are going to get your answer be x is equals to 3 or x is equals to 2. And next concept that you really ought to have understood as a candidate is to use quotient rule in terms of division. So quotient rule, you are going to assign this as v, and you shall assign this as your u. Then you, now in order to apply quotient rule, which is well seated here, we are going to find the u dx. The u dx is differentiating sine x, you get cos x, differentiating cos x, you get negative sine x. And also we have v, which is an exponent, differentiating this exponent that we have here. Something that you really ought to remember is the approach you use whenever you are differentiating an exponent. Because if you are differentiating an exponent, just your focus should be at the top. You are going to differentiate whatever that is in the power here. So the moment you differentiate that, you realize differentiating 1 minus 3x is going to give us just minus 3. So that answer minus 3 you have gotten times the original expression that you're having here, so that you shall have minus 3 e is to 1 minus 3x. So the power will be maintained the way it is, but once you have differentiated, you multiply it in front. Then you, now that you have dv dx, remember dy dx for quotient rule is v du dx minus u dv dx over v squared. So meaning that you are going to do substitution, and if you simplify the expression, you can leave it this way, the way it is. There's no harm, because still you will get all your marks, but I felt it's imperative for us to simplify the expression, and our expression will simplify to that. In this particular the integration that we have here, what I want you to remember is that sec squared x is equals to 1 plus tan squared x. So meaning this expression that we have here, we can be able to rewrite it in terms of sec squared x, and then once you have written it in terms of sec squared, this becomes integral of sec squared 3x dx, which is going to translate to, because if you differentiate tan x, you get sec squared x. If you differentiate tan x, you get sec squared x. So meaning that if you integrate now this, from differentiation we know d of x of tan x is sec squared x. So meaning if you integrate this case here, we are going to have our answer, integral of sec squared is basically tan x. So which means integral of this is going to be 1 over 3 tan 3x, and 1 over 3 is basically originating from here. Yeah, so remember that 3, if you differentiate whatever that is inside here, becomes 1 over 3. Instead of multiplying it in front, we are going to divide by tan 3x. So this is what our answer is. And don't forget to say plus c. And if you don't say plus c, means you're going to lose some 1 mark there. Then we have question 8, a question to do with some simultaneous equation. So which means that we shall take this part that we have here, we substitute anywhere we have an x at this point here and this point. So once we've substituted, we're going to get rid of the fractions. You can see the first thing I did is the substitution. Once I substituted, now I started multiplying all through by 2y into 1 minus 6y in order to get rid of the fraction. And expanding, you have to be very careful when it comes to expansion and removing the bracket here. Be careful with the sign so that you don't end up making a mistake, an arithmetic mistake in the process. Then now we have 16y squared minus 10y, an expression that is going to originate from here after removing the fractions. And if you factorize this, it's going to turn out to be 2y minus 1, 8y minus 1 equals to 0. And this implies that y is a half and y is 1 over 8. But since we are solving the simultaneous equations and this equation also was having x, then we are going to substitute. Anywhere you have y, we are going to substitute a half, and that's going to translate to minus 2. So that is one of the solution. In this case, this is one of the solution that we have. When y is equals to 1 over 8, we are going to have our x equal to 1 over 4. So you need to be very conversant on how you solve simultaneous equations, and you may be given questions which looks like this. Now in the diagram shows a velocity time graph, and this is actually kinematics. Under kinematics, you are given a velocity time graph here, and then you are told to sketch a speed time graph. So remember, speed time graph, velocity time graphs, you can have negative velocity, but in that case, speed will never have any negative velocity. So this part is going to be reflected on the y-axis. Yeah, so on the x-axis rather. So meaning this part of the graph that we are having here should be reflected up here, so that we shall have a graph like this. So you need to be mindful that speed cannot be negative. So that's why we are just reflecting that. It's given that the velocity of time graphs part of the quadratic curve has gradient 0 when time is 0, gradient 0 when time is 0. So meaning that if gradient 0 when time is 0, then it means that the gradient, the acceleration is also 0. When time is 0, acceleration is also 0. So that is why you can see I said here, when time is 0, acceleration also is 0. And then in this case, it's going to be a straight line graph passing through the origin. So the gradient also should be positive. So that's what you're expected to do. Then we have question number 10. The question comes from calculus, and that is area under curves. The diagram shows a curve y is x squared minus 9x plus 18. The line L is a normal to the curve at the point where x is equals to 5. So which means that if you do the y dx of this curve, you can be able to get the gradient function, which is going to be 2x minus 9. Then if you substitute that, you are going to get your gradient being equal to 1. So meaning that if the gradient of the curve is equals to 1, and this line is the normal at this particular point, then it means m1 times m2 is going to be equals to negative 1. So meaning the gradient of the normal is going to be negative 1. And then we can be able to use that in order to find the equation of that normal. In this case, we are going to find the value of y when x is 5, so that you can be able to use that to find the equation of the straight line. So if you substitute this x is equals to 5 into the original equation of the curve, we are going to get when x is equals to 5, x is equals to, x is equals to 5, y is equals to -2. Now if you have that point, we can be able to say now the point is where 5, y is equals to -2. So meaning that this is where that line, this line that we are having here, it passes 5, -2. But we know the gradient at this particular point is -1. So we can be able to say, since the gradient is -1 and it passes through that point, we can use the general equation of a straight line, which you shall say y minus y1 is equals to m into x minus x1. So meaning that y and x and y1 are points where that straight line passes. And also remember, m is the gradient and the gradient is -1. So if we substitute here y minus -2 is equals to -1 into x minus 5, then it means if you work out this, you are going to get the equation being y is equals to -x plus 3. This is the equation of the line. But we need to know what also this point of intersection is. So we shall take this equation and equate it to the equation of this line. So if you do that, you are going to equate it like this here. You put the like terms together and try to solve this quadratic equation. And you can see the quadratic equation gives us one of the point being x and the other point being 5. 5 is the point that we were given all true. Then the other point x is equals to 3 is this point that is here. So in order to work out the equation or the area of the shaded part, we are going first to, you can decide and find the area of this triangle here using a half base times height, and then you integrate the curve within the limits 3 to 5. So if you integrate that curve within the limit 3 to 5, then you get the answer, then you subtract the 2. But the way I approached it in my case, I decided to subtract the two equations first. So I subtracted the equation of the straight line from the equation of the curve so that I can be able to integrate direct and get my final answer. So first I took the curve, then I subtracted the equation of the straight line. Then now I got this expression that we have here. So this expression now, I can be able to integrate it. I integrated this and then substituted the limits, which gave me the final answers 4/3. 4/3 became the final answer. Next we have the question to do with permutation, and under permutation you are told the number of permutation of n items taken 4 at a time is equals to 1/6 times the number of permutations 2 items taken 3 at a time. So n items choose 4 can be written as this. You can be able to write as n permutation 4, and 2n permutation 3 can be written like that. But you ought to remember that a permutation means, if you want to write this permutation 4 is going to be n factorial into over n minus 4 factorial. The top number minus the bottom number, that's going to be n factorial into n minus 4 factorial, that is equals to, this one becomes, the top is 2n factorial over 2n factorial minus 3, this 3 that is here. So that you can be able to simplify that. I need now you to be very, very careful. Because we are having n minus 4 factorial down here, we are going to express the top until we have n minus 4 factorial. So whenever you are expressing n factorial, it means it's n into n minus 1. The next term will be n minus 2, n minus 3, n minus 4. So you can see at any given point we can cancel this guy and this guy here. And also we're going to look at the right side of the equation. 1 over 6, we can write it the way it is here. And then now 2n factorial, we need to write this until we have 2n factorial, 2n minus 3 factorial. So this is going to be 1 over 6 times 2n into 2n minus 1, 2n minus 2, 2n minus 3 factorial, so that this guy and this guy can cancel out. So this guy here will cancel with this guy here. And at the same time, this guy here and this guy will cancel. And then we are not going to have n factorial remaining at that point. So once we've gotten that, I want you to have your focus on this expression here. This expression we can be able to factor 2. We can be able to factor 2 here. Right? So if we factor 2 out, we are going to remain with n minus 1, and there is n minus 1 here, which is going to cancel. So ideally, that's exactly what I did, so that I remained with n minus 2, n minus 3 into 2 over 3. And the 2 over 3 is coming, the 2 that we have at the top here is coming from the factorization of this expression that I'm having here, so that we have 2 over 3, 2n minus 1 only. Then if you try to work out the equation and try to solve this, you will end up having a quadratic equation, and the quadratic equation is going to be this, of which if you are going to solve this equation, you are going to if you solve this, you are going to get your value of n is equals to 5. And of course, you are not going to get exactly 5, but you are going to get, yes, you are going to get 2 answers. What I mean is that you are going to get 2 answers. So if you are going to get 2 answers, you ensure that you are going to take a whole number, because those are, the n was representing number of items. So in that case, you have to ensure that the answer you will take here is only n is equals to 5, which is a positive value. Moving to hence, all right, so I think at this point I jumped the gun. You were supposed just to form the quadratic and stop there, but now in part B, that's where you are to solve the value of n by solving the quadratic. And if you solve it, you can see you have 4 over 3 and n is equals to 5. So we are going to take this as the only answer in this case. So we are going to take the positive integer only. And next we have a question to do with vectors. It was quite an interesting question, a good question. And in this particular question here, we're told that relative to an origin or position vectors of points A, B, and C are OA 17, OB 74, OC K 1 over 1, 2, and K is a scalar. Given that C lies on line AB, so which means that on line AB here, C is going to be somewhere there. That's why I placed it there. And you see I'm saying now AC must be parallel and AB are parallel. So that one you have to put into consideration, because C is lying along AB. Now point C lies on point AB, so AC is equals to MAB. So meaning if C lies between A and B, then it means that AC is actually a given number times AB. So if you have AB, there exists a number you can multiply by it to get AC. So meaning that before doing anything else, we are supposed to find what AB is. And from A to B, you have to move from A to O, then O to B. Yeah, you have to use that route. And when you're moving from A to O, remember you are going against the arrow, then it means it will be negative of O to A. So that's why you can see in the second part I've said AB is OB minus OA. And if you subtract these position vectors, because OB was this and OA was this, you are going to get 6, -3. So AB is 6 minus 3. We need also to find what AC is. And for you to find AC, you need to move from A to O, then O to C. So which means that this is going to be AO, which is against the arrow, which is negative OA, plus OC. So which of course becomes -17 plus K 2K, and the K2K is coming from this point here. OC we are given to be K, so I've distributed the constant K into it. Then now since we have AC and we have AB, we can now substitute that into the equation. AC is equals to MAB. So AC is K minus 1 to K minus 7, and M here, AB was 6 minus 3. So ideally, if you try to take the component X components and the Y components, you are going to form two equations. And if you try to solve the two equations simultaneously, maybe by substitution, you are going to get the value of M is 3/5. M is 3/5. So which means if you have 3/5 as M, then from here AC is equals to MAB, you can be able to express AC over AB, and that is the same as 3:5/5. And in ratio form, you can be able to say AB ratio AC is 3:5. So up to that point, that's what you are supposed to do in this non-calculator paper of October-November 2025. And if you are new to Proflan, see you the next time.